Hi, my name is Trudy Chandler, and this video, which will be my final project for GTech 101 at Hunter College, is related to how GIS can and has been useful in the field of urban forestry. This video will be based upon 3 case studies done in 3 separate cities that have used GIS to augment their urban forestry management. I've decided to do this in order of which cities I felt used GIS, if not to its full potential, the best in comparison to the others mentioned: New York City, Singapore, and Buffalo, New York. So what is GIS? According to Esri, the international supplier of GIS software, it is a geographic information system that integrates hardware, software, and data for capturing, managing, analyzing, and displaying all forms of geographically referenced information. So what does that mean? It means that using this technology, we're able to merge data with spatial information in a way that helps to solve complex problems that would otherwise be either time-consuming or impossible. The topic we will be exploring through GIS, urban forestry, is the field involved in the maintenance of city tree populations. This field is especially important because trees and other green spaces provide solution to some of the biggest problems presented by urbanization. By using GIS, objects in space, such as trees and green spaces, can be connected with other important information that helps us to assess and mitigate common problems associated with urban areas. Urbanization relates to the increased rate of growth in urban areas as people from the suburbs move into metropolitan areas in search of better jobs and living conditions. It is estimated that by the year 2050, the population of most major cities will nearly double. Because of this trend, the need for the systems that can provide urbanites with clean air and water has become ever more essential. Some of the concerns, among many, surrounding urbanization is combined sewage overflow, as well as urban heat island effect, problems that trees and green spaces can play a very important part in mitigating. I will be starting with New York City's model for urban forestry management. Central Forestry is a division of New York City Department of Parks and Recreation. They are responsible for the maintenance of over 5 million trees, which involves pruning, planting, and overall care of all urban trees and foliage in the 5 boroughs. Central Forestry has had 2 tree censuses in the last 2 decades, one in 1995 and another in 2006. These were accomplished with the help of volunteers who were provided with basic training on tree identification and paper maps. This information was then added to Central Forestry's first database, originally named Tree Manager and now called Forms, short for Forest Management System. In order to create a spatial reference for the trees, they used a special feature of ArcGIS called geocoding. This was based off of the address information that was provided by the volunteers and is still the method used by New York City Parks when creating references for 311 requests. Here we have 2 great examples of how Central Forestry uses GIS in their management practices. These 2 maps, created in GIS, reflect the effects Hurricane Irene had on the city's tree populations. Multiple layers of information were used to make these maps, such as natural boundaries, tree locations, as well as information provided by 311 service requests. One shows the density of trees down, while the other shows the severity of the requests made. Both maps help foresters gauge the severity of the damage and what requests should take priority over others. An important thing to keep in mind is that urban forestry management is not only important for the preservation and maintenance of these important assets, but they also hold a responsibility to the public to be able to provide them with quantitative progress of their work in reference to their involvement in different New York City green initiatives. 2 such important initiatives are the Green Streets program, as well as Million Trees NYC. Both initiatives seek to combat combined sewage overflow issues. Green Streets, a program created in 1996, is centered on the conversion of traffic islands and medians into green spaces. Million Trees, as you may already know, is the green initiative based on planting 1 million more trees in New York City within the next 10 years. Using GIS, Central Forestry is able to combine important information onto maps that they can then bring to community board meetings, city council meetings, as well as display these on their website to garner public and political support for their programs. GIS helps them effectively and more accurately connect the public with their progress. Our second case study is based on the island state of Singapore. NParks, the city's urban tree management department, has a central database similar to that of New York's, which is called Prime. The major difference between New York City Parks database and that of Singapore is that Prime is hosted on an ArcGIS server. Not only can GIS merge important data with spatial information, but it's also capable of linking this information with other devices. Using a GIS server, users can access and organize data and essentially create their own maps using shared information. NParks has over 150 workers that oversee their 1.3 million trees. In the management of these trees, workers use pocket PCs that are equipped with an ArcPad application that allows them to update information instantaneously into the central Prime database. This impressive feature is unfortunately not being used here in New York, I assume due to budget constraints. The part I was most impressed with by Singapore's use of GIS for urban tree management was their aim at creating a more integrated government. They use a web-based system called LandNet that allows over 15 government agencies to share information based off of the Prime database. This fully customizable system allows agencies who may have little to no knowledge of GIS the ability to create spatial information to fit their needs. For example, their Land Transportation Authority uses LandNet to analyze traffic and roadway conditions. The integration of all these government agencies is what I felt made Singapore's use of GIS more efficient when compared to New York City Parks' model. It is that use of the GIS server in connecting government agencies that I felt made it stand out. The following and last case study is done on the city of Buffalo in New York State. A historic storm in the early winter of 2006 damaged 85% of their tree population. Having been declared a major disaster by the federal government, they were provided with funding from FEMA, which they decided to put towards incorporating GIS technologies in their restoration efforts. Fortunately, Buffalo had kept an extensive catalog of their tree population since 2001 and had a company who handled their urban tree maintenance, Wendell Architects and Engineers. The system they had at the time of the storm was largely paper-based, something that Wendell felt needed to be changed in light of the demands that needed to be met after the storm. This was a problem that could only be solved using GIS. In response, Wendell created a program called the Urban Forest Tree Management. The system was a combination of an ArcGIS server with ArcIMS technology, very similar to Singapore's Prime and LandNet in that agencies could access up-to-the-minute information, create a customizable web-based GIS site, and create spatial information to fit their needs. Their online server stored a tree's complete history. Some of the information that could be accessed included when a tree was planted, the type of tree, the street it was on, the tree ID, any history of complaints made through 311, as well as the history of contracts connected to the maintenance of the tree. The major difference, and what I was most impressed with, was that not only could different government agencies share in this information, but independent contractors could as well. The need for these outside contractors is a reality in all urban tree management. Using this web-based application, contractors were not only able to, for example, update when they had completed their work, but also follow this with a request for an inspection from a city forester. This advanced integration not only helped them in their efforts to restore their tree populations, but I'm sure all the government agencies that need access to this information are reaping great benefits from this increase in efficiency. In closing, I hope I've been able to help you understand what geographic information systems are and how they can help in creating more efficient management systems, specifically as it relates to urban forestry. By using the 3 case studies, my goal was to highlight how geospatial technologies and tools can be utilized to make sense of complex but important data. My hope was to also give you a sense of the potential benefits of GIS in other management systems.